that ends that part. And I'm going to do this real quick. So problem with neural networks. Switch out of that. Problem with neural networks is that we need to be able to understand that they're great, but they are too deterministic and focus on they get to an overfit situation. So when you want to learn something new, you can't actually use a neural network. You're too stuck in one domain. And that's why learning something new, you need to bring in some amenity or bring in something new that doesn't exist before. Neural networks have a problem with adapting. So building a level of abstraction is what we need to do with our neural networks, or at least need to do with our AGI. Abstraction is good because what you do is whatever you think about something, right? Think about you have 10 items you need to go to the grocery store, right? You add a new item in, talking about you need to service your car. Now, automatically, does that fit in with your theory of mind, or at least your concept of dealing with the grocery store? No. So you rebuilt your abstraction levels. Okay, well, now I need things I need to do. And now broke it up into two buckets. One is go to the grocery store. One is go get my car serviced. And this is continuously happening, constantly, rebuilding and reshuffling things around. That's what an AGI system needs to do. It needs to build level of abstraction, not one time, but infinite times. Every thought almost rebuilds a new abstraction every time. So curiosity is our max of error. I'm getting kind of goofy with the equation there, but basically the largest error allows for more curiosity because you're not too optimized. So for example, if you have a day where you did something different than normal, not because you wanted to, because you happen to fall into it because things didn't work out the way you wanted to, you end up probably seeing something different that you haven't seen on a normal day that spikes a whole different level of direction that you can go in. That is what we call the largest error in the system, creates curiosity. And that's good for an AGI. So what can AGI can and cannot do? So AGI can deal with 100% life experiences or data feed. That's learning. That's kind of what it does now. But it cannot change its model. The same way we can't change our brains. Over time, there is some plasticity, but we can't change that, but very little. But then there's also changing the code and algorithm, basically changing the laws of physics. It can't do that. But the problem with AGI is it probably could change its own code. And that's something that's a partial risk. All right, so recognition and regression. Why do I say this? Because I said before, with recognition and regression, you literally are learning new things that you have not learned before. So for example, 2 times 3 is 6, and a kid learned this. Actually, my little girl done this last night. Where 2 times 3 is 6, 2 times 4 is 8, and predict the next value. Now, you may already know this because you've done it before, but what happens if you have never done it before, your brain has to use something that it hasn't done before, and it's not neural networks. It has to be able to regress through and figure out what that value is based on a collection of sample size you already had. So where do I go with this? So your working memory constantly pushes this over and over again, and what it does is in your working memory, I pull in, now I'll make this up, I say memory ID, whatever number, 1,000,002, whatever number it may be. But what I'll say is I'll pull all this into my short-term memory, and I will use some kind of learning mechanism or system to help me reason through what X is. It's not something you do passively, it's something you do with your new brain or your system 2 brain. Questions? Is that a lot? All right. You guys want to take a quickie, or you good? This one's a little shorter. You good? 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 All right. So this is now getting to building AGI.